Hi, today I will explain how to generate a synthetic data using Python and Google Colabs. So we can go to Drive. First, we want to go to Drive. And after that, we can create a new folder, for example, project, synthetic data. And we can create here a new Google Colab notebook. We can create. Okay, synthetic data means data that we create artificially using a mathematical equation instead of collecting it from a real data set. This is very useful in teaching because it helps us to understand how machine learning works in a clean and controlled way. For example, I want a model to learn a relationship between input and output, and I can create that relationship myself using an equation. Then I can also add noise to make the data look more realistic because in real life data is usually not perfectly clean. We will use this equation. I will add a text and I will put it above here. We will use this equation y equal 0.5 multiply with x to power 2 plus 2x plus 3 plus noise. We can add this equation here as a text, and after that, and this equation, it means the output depends on a three parts, a quadratic term 0.5x square, and a linear term 2x, and a constant term 3. Then we will add a noise which represents random variation or measurement error. Okay, first x is the input, and the second x square means we square the input. This creates a curved relationship instead a straight line. Okay, why we need noise? Because without noise, every point would follow the equation exactly. But with noise, the points move a little above or below the true curve. So the noise is a random value that we add to make the data less perfect and more realistic. We need first to import NumPy library, NumPy as NB, and we need also a matplot library for plotting. And we can run the cells, and we can create, if we want, we can create cell 1, for example, import library. Shift and enter to run it or to execute it. And after that, we will create a random number generator because we want the same seed and we want to get the same random value every time, which is useful for teaching and reproducibility. So we will create RNG equal mb.numpy random dot default RNG 42. and this number it's called a seed. We know it before. After that, we will create 100 evenly spaced value from minus to 10 to 10, for example, and these are our input values. X equal MB dot line base minus 10 to 10, and we will create 100. After that, we will create the random noise from a normal distribution. So we need a noise equal RNG dot normal, and we will give look equal 0, and this means the mean of the noise is 0, and we will put another parameter scale equal 5, and the means or the standard deviation here is 5, and we will put the size also equal len of x. It means the generate one noise value for each x value. So every input point gets its own random distribution. Now we will put the equation for us, y equal 0.5 multiply with x to power 2 plus 2 multiply with x plus 3 plus noise. And we can run it. And this is the main synthetic data equation, and we compute the clean mathematical pattern first. After that, we will add the noise. So we need to plot the value, uh, I generate it. Plot dot figure and figure size 10, 6, for example, and we will plot a scatter for x and y, and we will put a label here equal data, and we can put labels for x and y, and we can put also the pt dot title and static data generation, and we want to plot to add a grid line. We can add it plot dot grid true, and we can run the cells and we can see the value here. Okay, how we can print the value? We can print, for example, x value. It gives us all the value for x. And we can print also the y. It gives us also the all random value. And we can print it like, for example, a table or sorted data, I mean. for I in range len x, print f index, and we will put I here, and x equal for I, and noise, noise I also, array here, yeah, and y equal y of I, and we can print. And all these data we generate at 100 line. Okay, how we can put the title for the Jupyter Notebook? We can put the title here, or the collapse. I need to explain one thing to you. Jupyter Notebook, it's uh, the same for collapse. So you need to make it in collapse. You didn't need to make it on the Jupyter Notebook. But Jupyter Notebook, it's supported by Anaconda software. You can download it if you want to work on your machine. You can download Anaconda, and after that, you can open the Jupyter Notebook. And Jupyter Notebook, it contains the same cells and the same way for working. And we can put here generate data. How we can download this file, for example, we can go to Drive to download it. With this format, you should submit it on LMS, or you can download it from download here and choose the first choice. Thank you. See you in the next lecture.